Hi, welcome to the Moon Unit. It is the next unit you'll do after the solar system. Right now, you're working on your space mission projects, and those are fun to do. Just pick a space mission, either past or present, current. Just make sure you haven't duplicated each other and have fun with it. Put a lot of pictures in there. Tell each other what the mission was about, what it learned. Have fun with it. Make it enrichment. So the moon, again, as you prepare for the test, which you should be doing right off the bat, is listen to these notes, study them, do the textbook work that I'll assign you in class, look over those questions, and then any activities we do in class, like we have a moon activity where you label all the Maria and some of the big rays and craters. Just label those, have fun with it, study it, know it. All right, so Luna is Latin for the moon. That's big, bold, and red. Hint, could that be a fill in the blank question on the test? Well, heck yeah. All right, so lunar exploration. Until 1950, all the moon research was done by telescope and naked eye. We didn't have spaceships going up there. Russia beat us there with Luna missions. They provided the first spacecraft to fly by, to orbit the Earth, to orbit the moon, and to land on the moon, or crash on the moon. So Luna, Russia beat us in 3 accounts. Luna 1, first to fly by the moon. Luna 2, first to crash into the moon. Luna 3, first to orbit the moon and first to send pictures of close-ups of the surface. So America followed behind with our pioneers. Remember the pioneers of America, those who walked across the new land. So think of pioneer as USA. we were competing with Russia at the same time they sent out Luna. But our Pioneer 1 through 3 were not successful. They did not fly by, they did not crash in, and they did not orbit the moon. However, Pioneer 4 finally is trying to catch up. It flew past the moon and gave us some pictures. Then we sent Ranger missions. They're out there to be rangers, and they came back with pictures of landing sites. But they did not land, they crashed on the moon. But hey, they found nice landing sites. So then we sent surveyor missions. A surveyor is someone who actually collects samples, right? So the surveyor lunar probes actually landed on the moon and tested the regolith hardness. What is a regolith, you ask? Well, the moon does not have life growing on it, doesn't have trees or leaves, so there's nothing living in the rock material. So crushed rock is called regolith. We call it soil here on Earth because soil consists of rock and organic debris. Ah, there she is. Soviets' Luna 9 was the first probe to safely land on the moon, and it led the space race. Some accomplishments: the spacecraft made the first survivable landing, sent pictures back to the Earth, beating America's Surveyor lander by about 4 whole months. That's a long time. Luna 9's landing was harder than that of the Surveyor, but good enough for its camera and radiation detector to survive and do their jobs. The mission proved that a lander would not sink into the thick layer of dust as some models predicted. We thought, man, this moon's been crushed by meteoroids and micrometeoroids for years. It's going to be one big puff, one big sand volleyball pit, basically. So then Mercury and Gemini. Muy importante. Mercury is the first American spacecraft to carry an astronaut. There's room in there for barely one. If you saw the years ago at the Science Center, they had a model of the Mercury. It was tiny. I could barely get in there. So Mercury had Alan Shepard fly his first missions in Mercury 3. John Glenn was the first American to orbit the Earth in Mercury 6. He was then later the oldest man to go into space. Amazing physical fitness to have to go back up in space again at basically my age now. He was old. So, pretty amazing. John Glenn, good to know. First American to orbit the Earth and oldest man to go into space thus far. Gemini missions happened around 65 through 66. There were 10 missions. They carried 2 astronauts. Think of Gemini twins, right? So that helps you remember 2 astronauts. They tested the weightlessness. They trained astronauts to control the craft, getting them ready for a land-manned mission. Of course, You know the first land manned mission? Apollo. Apollo is the first one to carry men to the moon. The Apollo missions were very important. The first 3 people to the moon, or 2 people actually stepped foot on the moon, were Neil Armstrong and Edwin Aldrin Jr. Edwin went by Buzz Aldrin. If you write Buzz Lightyear on the test, I'll mark it all wrong. It's Edwin Aldrin Jr., Edwin Buzz Aldrin Jr. They're the first men on the moon. Michael Collins remained on board. Someone had to. So the poor guy never stepped foot on the moon, but still important. They brought back samples of the regolith, the hard, granular, sharp, fragmented, minute Rockies. So they also left instruments to measure moonquakes. Moonquakes are like earthquakes, except for on the moon. The magnetic field of the moon, believe it or not, there's a weak magnetic field there. Solar wind particles, because there's not much of a magnetic field to block it, the solar winds blow through there, and it's dangerous even for the astronauts. And the atmospheric gases. Although the atmosphere is very tenuous, very thin, pretty much non-existent, there's still some gases there held by the gravity of the moon. All right, our space shuttle came in. First one designed to be reused. I mean, the shuttle itself. The propellants, no. So it had 3 main units: the orbiter, which is the body, the external tanks, which fed the fuel just to get it out of our gravitational pull for about 10 minutes, 2 solid rocket boosters for the initial liftoff, and then a remote manipulator system, an RMS, a big old 50-foot arm that went out there and would grab stuff in space. So here's a cute little diagram. At liftoff, the 2 big solid boosters, boom, boom, and they're gone. That got the initial acceleration going. And then the fuel tank gets you out of the gravitational pull of the Earth, or at least the bulk of it, get you out there where now it can float around out in space. And then reentry, you can see the bottom there, reentry, how red hot it is. It had a heat shield down there, so it would absorb that heat so the astronauts wouldn't bake. Okay, properties of the moon. The moon is roughly 1/4 of the Earth's diameter. Doesn't sound big, but in comparison to other natural satellites, it makes it the largest natural satellites in terms of the size compared to its planet. So a natural satellite that is 25% the size of its planet is big in comparison to the planet. So that's the moon. Density is only 3.3 grams per mil, which is less than the Earth, about half as much as Earth. Earth is 5.5 grams per mil, is our average density. The gravity on the Earth is 1/6 of the Earth's. Very low escape velocity, 1/5 of the Earth. So it doesn't take much for the orbiter and stuff, Apollo, to get back off the moon because it's got 1/5 less gravity, so it's easier to launch. If you were on the moon, you'd weigh about 1/6 as much as you do here on Earth, just because you have less gravity, which means you could jump really high. Measured moonquakes for 8 years to figure out just what's going on up there. Lunar Maria. So Mare, as you see in the little diagram on the left, M-A-R-E, is Latin meaning seas or oceans. For years and years and years, men would look up there and think, oh, look at the oceans or the seas up there on the moon. They thought those were oceans, and they kind of were. They're oceans of lava, which spilt out when something big hit it, and the hot magma underneath came out as lava and filled the basin and quickly dried up. So they're big, smooth plains with circular basins. The Mare rock is similar to that of the Hawaiian lava flows. What a coinkydink. They're basaltic rock, or dark basaltic rock, and you can see that by looking. It's dark. Moon gravity is greater over the Maria because the Maria are more dense. They haven't been pelted by micrometeorites over years and years and years of meteoritic pounding. So mass con, they're called mass cons, that area of a lot higher gravity, it's just called a mass con, which means a mass concentration of gravity. Oh, that's a big, bold red word. Could be on the test. Rills are long, deep cracks along the Mare bedrock. If you have your red and blue, the 3D glasses, the picture on the right there pops. You can see Hadley's Rill, a really big, deep canyon on the moon. So just like on Earth, when we get a hot summer day and you get mud formed, If it dries fast, the mud gets little cracks in it. Same thing with the lava. It cooled so quickly, it formed big cracks or canyons. All right, stuff you need to know up here. You don't need to know the Mare Procellarum. However, number 2, Mare Imbrium, you need to know that one. Mare Serenitatis, number 5, Sea of Serenity, need to know that one. 7, right below it, Sea of Tranquility, Mare Tranquillitatis, got to know that one. 8, Mare Crisium, Sea of Crisis, got to know that one. Oh boy, there's a lot on here. Tycho is there. They don't have Copernicus or Kepler labeled on this one, but that's okay, you label them. These are just some ways they name the moon. The craters, obviously, Tycho, Copernicus, Kepler, named after famous scholars and astronomers. And the Mare, just named after oceans, or however we want to name the oceans. So Apollo moon landings, kind of cool. We found places they could land. Notice they found them right close to the Mare or in the Mare. So it's nice, pretty solid area, flatter area. They try to avoid ridges where they tumble. And if you look at this picture, yeah, they got a rod going across the flag to keep holding it up because there are only real winds up there, solar winds, and yeah, they're nasty, but there's not much atmosphere for wind, like as we know it. The atmosphere is black. The sky is black because there's not an atmosphere to diffract the sunlight, so it's just black. The gravity on the moon, again, is about a sixth of what it is on Earth. So if you weigh 200 pounds on Earth, you only weigh 34 pounds on the moon. That's light. So the lunar highlands, they're brighter because they've been eroded through micrometeorite, that's what hits it, is right, meteorites, erosion over time. So most of the mountain ranges are at the edges of craters and mare. Why are the mountain ranges at the edges of the craters and the mare? Why would it be taller, these ranges around the mare? Well, let's go back to mud. You got a nice flat pool of mud that's drying in the summer heat, but it's still muddy. You step into it, you walk across it, and you come back a day later, and it's all dried. Where's the high point going to be? Around the edge of your footprint where the compression forced the material to the edge and made it rise like little mountains. So that's why the mountain ranges are higher at the edges. The moon mountains formed that way, not through plate tectonics like we did here on Earth. There's a nice picture of a crater, and you can see the moon ridge and the shadowing. Lunar craters and rays. Craters on the surface are formed by impact of meteorites. Big meteorites make, the bigger the meteorite, the bigger the crater. The largest is Clavius at 240 kilometers in diameter. It's over 100 miles in diameter. It's big. The rims of craters may be thousands of meters above the plains. Again, they're mountains, formed from the impact pushing the edges up. Craters are named after scholars and scientists. That's really good to know. It's in bold red. Rays. Now you take this snowball, a dirt clod, and you throw it against a brick wall. Boom. What happens? You get bits and pieces fragmenting out in rays. You ever done that? Throw a snowball at something that radiates out? Same thing here. The meteorite which landed there exploded and shot out, making all these rays from the craters. The regolith, again, is the name of the lunar soil, but it's not soil because there's no organic or living detritus in there in water. It's just basically loose rock formed from micrometeorite bombardment. Micrometeorite, that's important. I put it underlined and bolded in red. Yeah, so it's sharp and angular and very sticky. It's nasty stuff. So if you click on this, it'll talk about the Graben, and Haben, basically fault structures which form canyons on the moon. All right, the moon has what's called a synchronous rotation. That means what we see facing us will always face us. The moon orbits us and rotates in its axis the exact same. It always faces the Earth. It rotates and orbits 27.3 days. So we always see the side facing us. The side away from us we call the dark side, even though during a new moon, it's lit up and front facing us is dark. So the moon orbits from west to east.